Hi, I'm Shantia Meekum. Here's my ID. And tonight I'm going to be doing the problem on page 211, number 19. The question, it's about how many people have confidence, little confidence in newspapers. It says 34%. If we randomly select 8 U.S. adults, I need to find the probability that the number of adults who have very little confidence is exactly 6 and then less than 5. So for this we use the binomial probability formula, which is the probability of x equals ncx times p to the x q to the n minus x. And to find ncx, it's n factorial over n minus x factorial x factorial. N is the number of trials, x is the number of interest, so that's the 6 or the less than 5. P is the chance of success in a single trial, and Q is the chance of failure in a single trial, so P plus Q always equals 1. For this problem, the chance of success they gave to us at 34%. Just take 1 minus 34, or 0.34, and you get 0.66, so that's the chance of failure. Okay, so we're going to start out with part A, where we want to know the probability that it's exactly 6. So x is 6, n is 8, that's the sample size that they gave us, so it's 8c6 times 0.34 to the x, which was 6, times 0.66 to the n minus x, so 8 minus 6, which is 2. First we're going to find this part, the 8c6, so that's 8 factorial over 8 minus 6 factorial, 6 factorial. So it ends up being 8 times 7 times 6 factorial, and then this and this will cancel out. So we're left with 8 times 7 divided by 2, which is 28. So now what we'll do is we'll come down here, so we have 28 times 0.34 to the 6 times 0.66 to the second, and for that we end up getting, so 28, 0.34 to the 6 is 0.00154, 0.66 squared is 0.4356, and when you take all these multiplied, you get 0.19, so 19%, and that's our answer for part A. There's a 19% chance if you select 8 adults that exactly 6 of them will have little confidence. So to find the second part, where we want it to be less than 5, what we do is we find the probability of every number that's less than 5 and then add them up. So we'll find the, so x can be 0, 1, 2, 3, or 4. So we start with the probability of 0, so 8c0, 0.34 to the 0 power, times 0.66 to the 8 minus 0 is 8. So 8c0, 8 factorial over 8 minus 0 factorial times 0 factorial. It just ends up being 1. 8 factorial over 8 factorial. Anything to the 0 power also equals 1. So we really end up with 1 times 0.66 to the 8, which is 0.036. And so that is 0.036. So 3.6% chance there on that one. Let's find the probability that the answer is 1. So here's the binomial probability formula. We're going to take 8 factorial over 8 minus 1 factorial, 1 factorial. So we get 8 factorial over 7. So that's going to be 8 times 7 factorial over 7 factorial and 1. And so these are going to cancel, and so this ends up just being 8. And then we're going to have 8 times 0.34 to the first times 0.66 to the 7th, which was 0.055, and the answer ends up being once you take these three and multiply it, you get 0.150. So it's 15%. So now we're going to do the same thing for P2. And I'm going to skip ahead to this part. So we get 8 times 7 times 6 factorial. These two cancel. So we end up with 8 times 7 divided by 2, which is 28. And then we're going to take 28 times p squared times q to the 6th. And we end up with 0.27, so 27%. Do the same thing again for number 3. These guys are going to cancel, so we're 8 times 7 times 6, and then we're going to take that by 3 times 2 times 1. So basically it ends up being 336 over 6, and then that equals 56. And then same thing, you're going to multiply it all out, and we end up with 0.273. So this is 27.3%. Repeat everything with the number 4. The 4 factorials are going to cancel out, 8 times 7 times 6 times 5 is 1,680 over 4 times 3 times 2 times 1 is 24, and that equals 70. And then when you multiply all this out, you end up with 0.173, so 17.3%. And so to find the probability that x is less than 5, you just add up the sums of each one of these that we found for x being 0, 1, 2, 3, and 4. So we take 0.036 plus 0.15 plus 0.270 and so on. And ultimately you get 0.902. And that is the final answer.